Okay, so we're going to talk about the classifications of real numbers. So saying real numbers implies that there's non-real numbers, and there are, but we're not going to deal with that in Algebra 1. Okay, so there's a couple different categories we're going to define. Each one has its own letter that we use to recognize it. The first one being the main category, which is real numbers. Okay, real numbers gets the letter R. Okay, so capital R with an extra line through it means all real numbers. Okay, so that's the main set we're going to deal with. Okay, and then everything is going to be, that's the biggest umbrella, everything's going to be under it, kind of in a nested way. So anything listed below it is also in the category above it. So the biggest category for real numbers is rational numbers. Okay, rational numbers, we can't use R again because R is for real numbers. So what letter should we use for rational numbers? I don't think anyone will guess it, but we use the letter Q. Okay, so capital Q with an extra line through it. Okay, why do we use Q? Okay, well, if you think about what a rational number is, if you know what a rational number is, it'll make sense. But we use Q to stand for quotients. Okay, so quotients means a division. A quotient is a division operation. Okay, why do we use quotients? What do quotients have to do with rational numbers? Well, a rational number is any number that can be written as a fraction. Any number that can be written as a fraction. So think about some numbers. Well, 5 is a number. Can you write 5 as a fraction? Yeah, you can. 5 over 1. 5 is a rational number. 1/2. 1/2 is a fraction. That's also a rational number. Right? So anything that can be written as a rational number. So all fractions, all numbers you could think of. What else counts as a rational number? Well, decimals. Decimals that end are rational numbers. So decimals that end are called terminating decimals. Terminating just means it ends. So there's not a dot, dot, dot at the end. It's, however, it could be 100 digits, but as long as it stops at some point, you could write that as a fraction, which makes it a rational number. What else counts? Well, repeating decimals. Repeating decimals are things like 1/3, 0.33333. It keeps going forever. Okay, those don't end, but if it does have a repeating pattern, you can write it as a fraction, and if you could write it as a fraction, it counts as a rational number. Okay, so all rational numbers are also real numbers. Okay, remember, anything above it is part of that category. Under the rational numbers umbrella is a category called integers. Okay, what letter do we use for integers? It's not I, it's actually Z, so capital Z with an extra bar through it. Okay, usually down the diagonal. Okay, so integers, all integers are rational numbers, but not all rational numbers are integers. An integer is a number that can be written without a decimal or a fraction part. Okay, so above it we had rational numbers, which are all numbers that can be written as a fraction. Integers kind of takes that away. It's any number that can be written without a fraction or without a decimal. Okay. So 5 again. 5 can be written as a fraction, but it could also be written not as a fraction. So 5 is an integer. 1/2, 1/2, can be written as a fraction because it is a fraction, but it can't be written not as a fraction or not as a decimal. So 1/2 is not an integer. So again, any number that can be written without a decimal or a fraction part. So integers, all integers are rational, all integers are also real. So again, that's how these kind of stacking umbrella categories work. Okay. Underneath the integer umbrella are whole numbers. Okay. Whole numbers get a W, as you might guess, with kind of an extra line through it. I've seen the extra line in the first kind of slant of the W. I've seen it kind of in the middle slant. It doesn't really matter. We don't write it that much. Okay. Whole numbers are positive integers. Okay, so integers include negative numbers, but whole numbers do not. Okay. So whole numbers are all the positive integers, and then there's one extra number, the number 0. Okay. 0 is neither positive nor negative, but it is a whole number. So whole numbers are positive integers and 0. All right, and there's only one more subcategory, and it's the category of natural numbers. Okay. Natural numbers get an n. Okay, an n with an extra line. Again, usually it's down the diagonal in the middle. Sometimes it's at the end, sometimes at the beginning. But a capital N. Okay. Well, what's a natural number? Natural numbers are all whole numbers. Whole numbers are integers. Integers are rational. Rationals are real. But more specifically, what's a natural number? Natural numbers also are called counting numbers. Okay. So these are the numbers you count with. All right. So when you start counting, what do you start at? Do you start at 0? You don't. When you're counting something, you start at 1. Okay. So counting numbers or natural numbers are all the whole numbers, but not 0. So it's all the positive integers, not including 0. 0 is not positive. It's not natural. Okay. It's also, things you could count in nature. Okay, that's why it's called natural. You can't really see nothing. You can't see 0. You could see 1 cat or 2 dogs, but you don't see 0 cats. Okay. So that's why those are called natural numbers, things you could see in nature. All right, so again, all of those categories are kind of nested into each other. Okay. So not all rational numbers are integers, not all rational numbers are whole numbers, but going up backwards is true. All whole numbers are rational. All whole numbers are integers. Okay. Now, rational numbers was the main category in there. There are irrational numbers that we're going to talk about. Irrational numbers get the I, which is why integers didn't get I. But usually we don't really, if it's irrational, we don't really mess with it that much. Okay. Well, what's an irrational number? Well, it has to be the opposite of the definition of a rational number. Okay. Rational numbers were numbers that can be written as fractions. Rational numbers were decimals that ended or decimals that repeat. Okay. So an irrational number can't include any of those. Irrational numbers are going to be non-terminating and non-repeating decimals. Okay. So decimals that don't end and there's no pattern. There's nothing that repeats. Non-terminating, again, that means not ending. Usually there's going to be a dot, dot, dot at the end. There has to be a dot, dot, dot at the end of the decimal to imply that it keeps going forever. And non-repeating, so there's no pattern. You don't see anything. It's not the same number repeated over and over again. It's not the same set of numbers repeated over and over again. Non-terminating, non-repeating decimals. And there's one other category. Some examples of non-terminating, non-repeating decimals. Pi, that's one you're probably familiar with. And E, there's a number E that you're probably not familiar with, but it also doesn't end and also doesn't repeat. The other type of irrational numbers are square roots of non-perfect squares. Okay. Square roots of non-perfect squares. So perfect squares are any integer squared. Okay. 9's a perfect square because 3 squared is 9. 16 is a perfect square. 4 squared is 16. 100 is a perfect square. Okay, so any whole number squared is a perfect square. So the square root of non-perfect squares are going to be irrational. Square root of 2, square root of 3, square root of 42. Anything that's not a perfect square. If it was a perfect square, you would just write it as an integer. Square root of 100 is 10, so you would just write it as 10. All right, so those are all the classifications we have for real numbers. Again, irrational numbers are real. Rational numbers are real, so they're all under the real category. And then, integers and whole numbers and natural numbers fall under the rational number category.